Solution to the following system of inequalities. Here we have a system with not one, not two, but three different linear inequalities, okay? And so when we are graphing solutions for a system, we need to make sure that the points, the x and y points that are solutions, they're only solutions if they satisfy all three inequalities, okay? They can't just satisfy one or two. They have to satisfy all three of them at the same time in order to be solutions to the entire system. So let's go ahead over here on the left. Let's talk about each of these inequalities. So the first one, okay, we have has two variables, x and y, and it's in standard form. So the first thing we're going to do for this guy is turn it into slope-intercept form by isolating y. But let's also talk about the second one. We got x is greater than -2. This is going to be a vertical line, and y is less than or equal to 7 would be a horizontal line. Okay, so let's start with the first one. First thing we're going to do, let's remove the -2x from the left-hand side. That would give me 3y is greater than or equal to 2x plus 9. Then I'm going to divide by 3, since that's the coefficient of y. And that would give me y is greater than or equal to 2/3 x plus 3. All right, so I'm going to go ahead and I'm going to graph that in Alex before I graph the other ones. So let's come down here. The y-intercept is 3, so I'm going to put a point at 3. And the slope is 2/3, so it's positive. So I'm going to go up 2 units and to the right 3 units. And this is going to give me my line for that first inequality. And I want it to be a solid line because I have an equal to bar underneath the greater than. Now keep this in mind. It is a greater than, so we are going to want to shade above this line. So we already know that we are not shading here. So only above this line is going to get shaded. So let's now take a look at one of these other inequalities. So x is greater than -2. Well, that is going to be a vertical line at -2. So here is x and here is -2. And it's going to be a vertical line because all of the points along this vertical line have an x value of -2. So I'm just going to put another point along that vertical line so I can draw this. It needs to be a dashed line because it is greater than and it is not equal to. And now we need to decide where are we going to shade. Would we shade to the left of this line or to the right? Well, we want the x values that are greater than -2. And so if we look at the x-axis, the right side of the line deals with the positive x's, right? The x's are getting bigger, greater, and the left side of the line, they're getting more negative. Okay, so we're definitely going to be shading on the right side of the dashed line. So that helps us understand that we're probably going to shade somewhere in this region because we know that we have to be above the first line that we drew, and we now know we have to be to the right of the dashed line. So we know that we're not shading over here. And so the last one we're going to look at is this. Y is less than or equal to 7. So I'm going to go to y7, and I'm going to put a point here. And I'm just going to put another point right next to it so I can draw my horizontal line because all of the points along this horizontal line have a y value of 7. And so here we go. I'm going to draw this horizontal line. And it's a solid line because we have an equal to component. And so now we got to figure out, we basically have two options. We could shade up here, or we could shade inside this little triangle. All right, and the reason we have those as our options is because we know that we had to be above this line, we have to be to the right of this line, and so it all depends on where we are in relation to this new line. Do we shade above it or do we shade below it? Well, it is a less than inequality, so we want to shade underneath this line, not above it. So the only option would be this triangle in the center, okay? And I'm going to go ahead and press check to see if that's right. And it is correct, okay? And now I just want to prove to you that it is correct, all right? And so if we were to take a point from inside this area, let's say, let's just take y equal 5. Let's take 0, 5, all right? And let's make sure it works in the system. So I'm going to do that right here. If I test 0, 5, it needs to make all of the inequalities true. So first inequality, negative 2 times 0 plus 3 times 5 has to be greater than or equal to 9. The second inequality only has x in it, and so 0 has to be greater than negative 2. And then the third inequality is just a y, and so 5 has to be less than or equal to 7. Well, I can already tell that 2 of those are true. 0 is definitely more than negative 2, and 5 is definitely less than or equal to 7. And so the only question that I would have to do is this little bit of math here. And so let's just take a look at this. The left side would be 0 plus 15, which would be 15. And 15 is definitely greater than or equal to 9, so I know that it works for all three inequalities. All right, and remember, to be a solution to a system, the point has to satisfy every single inequality. It can't just satisfy one or two of them. It has to satisfy all three. All right, hopefully this was helpful.